In this module, we're going to talk a little bit about that wireless LAN configuration. So remote workers, small branch offices, home networks often use a small office and a home router. These integrated routers typically include a switch for wired clients, a port for an internet connection, sometimes labeled as WAN, and then wireless components for your wireless client access. These wireless routers typically provide WLAN security, DHCP, integrated name address translation, quality of service, as well as a variety of other features. The feature set will depend on the router model. Cable or DSL modem configuration is usually done by the service provider's representation or representative, either on-site or remotely. However, most do allow you to go in and kind of tweak things within your router. Things like if you have young children, you can go in there and, unbeknownst to them, you can go in there and you can change the hours that the internet is available so that if they sneak out of bed and they're trying to get on the internet, they can't get in, things of that nature. They will let you go in there and dabble a little bit with certain parameters. So it would behoove you to kind of look around and see what is available for you to play around with. Now, most wireless routers are pre-configured to be connected to the network and provide services. Wireless router default IP addresses, usernames, and passwords can easily be found on the internet. Therefore, your first priority should be to change these defaults for security reasons. So most vendors have universally known usernames and passwords that can be found on the internet. So do not leave your device with defaults. And a lot of times, most that I've gone into, different routers that I've gone into, the name is simply default. So you want to name it something, but don't make it something too crazy, because if you do, or when you do, not if, when you do the encryption part of it, it will be encrypted into a series of letters and digits and characters. So you may think that you're being quite smart in creating this very long password, but if you don't write that password down and you forget the password and you don't have that very long encryption, or even if you do have that very long encryption is what you're going to need to type in order to get back into your device. So keep it smart. Do what most people, most technologies teach you to do. Use your different things for different stuff. As an example, when you write access, you can write access like this. Something like that. Smith. Things like that. So you want to kind of switch it up so that it's not normal or straightforward, but change from default. To gain access to the wireless router's configuration GUI, you're going to open a web browser. You're going to enter the default IP address that your wireless router has on the back of it. The default IP address can be found in the documentation that came with the wireless router, or you can search the internet. Again, commonly the word admin is used as the default username, and there typically is no password. So you want to change the admin again to something that is going to identify your network and create a good username and password. Now, basic setup is going to include the following steps. You're going to log into the router from a web browser, utilizing the IP address either in the documentation or, like on my router, it's on the back of my router. Change the default administrative password. Log in with the new administrative password. Change the default DHCP addresses. Renew the IP address. Log into the router with the new IP address. Basic wireless setup is going to include the following steps. View your WLAN defaults. Change the network mode, identifying which 802.11 standard is to be implemented. Change the SSID. There should not be any identifying name. Configure the channel, ensuring that there is no overlapping channels in use. Configure the security mode by selecting Open, WPA, WPA2, WPA Enterprise, etc. and then configure the passphrase or the passphrase as required for the selected security mode. So in a small office or a home office, one wireless router may suffice to provide wireless access to all clients. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can create a wireless mesh. Creating the mesh by adding access points with the same settings, except using different channels to prevent interference. Extending a WLAN in a small office or a home has become increasingly easier. Manufacturers have made creating a wireless mesh network simple through smartphone applications. Now, adding for IP4. Typically, your wireless router is assigned a publicly routable address by your ISP, and it will use a private network address for addressing your LAN. So to allow hosts on the LAN to communicate with the outside world, the router will use a process called network address translation. This is not unfamiliar to you. Network address translation translates a private local source IP4 address into a public global address, and then the process being reversed for incoming packets back to you. NAT makes sharing one public IP4 address possible by tracking the source port numbers for every session established by a device. So if your ISP has IPv6 enabled, you will see a unique IPv6 address for each device. Now, many wireless routers have an option for configuring quality of service. By configuring QoS, you can guarantee that certain traffic types, such as voice and video, are prioritized over traffic that is not as time sensitive, such as email and web browsing. On some wireless routers, traffic can also be prioritized on specific ports. And so again, if you're not using a particular port and you feel comfortable enough, you can disable that port, but only if you feel comfortable enough. Now, your wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of the network. However, there are situations when specific ports must be opened so that certain programs and applications can communicate with devices on different networking. So port forwarding is a rule-based method of directing traffic between devices on separate networks. Excuse me. Port triggering is going to allow the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. This is common practice for online gaming. Now, the topology and addressing scheme used for this topic are shown in the figure here and in the table. So the access point is a controller-based AP as opposed to an autonomous system AP. You see the WLAN controller over here in the picture. So it requires no initial configuration and is often called a lightweight AP. LAPs use the lightweight access point protocol to communicate with their WLAN controller. So controller-based APs are useful in situations where many APs are required in your network. As more APs are added, each AP is automatically configured and managed by that wireless link controller. So configuring a wireless LAN controller is not that much different from configuring a wireless router. The WLC controls APs and provides more services and management capabilities. So the user logs into the WLC using credentials that were configured during initial setup. The network summary page that you see here is a dashboard that provides a quick overview of configured wireless networks associated with those APs and your active clients. You can also see the number of rogue access points and clients. You want to click on the access points from the left menu to view an overall picture of the AP system information and performance. Okay, the AP is using the IP address of 192.168.200.3. Because Cisco Discovery Protocol is active on this network, the controller knows that the AP is connected to Fast Ethernet 01 on the switch. Okay, so you're looking right at this very first generalized column. The AP in the topology is a Cisco ArrowNet 1850i, which means you can use the command line and a limited set of familiar iOS commands. Most controllers will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. For the Cisco 3504 wireless controller, you click the Advanced in the upper right-hand corner to access the Advanced Summary page. From here, you can access all the features of the wireless controller. Now, your wireless LAN controllers have a layer 2 switch port and virtual interfaces that are created in software and are very similar to VLAN interfaces. So each physical port can support many APs and WLANs. The ports on the WLC are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple APs. Each AP can then support multiple WLANs. So basic WLAN configuration on the WLC includes the following steps. You need to create the WLAN, apply and enable the WLAN, select the appropriate interface, secure the WLAN, verify the WLAN is operational, monitor the WLAN, and then view wireless client information. So the following steps are to come. Create the WLAN. In the figure, a new WLAN with an SSID of wireless_LAN is created. Then you apply and enable the WLAN. Next, the WLAN is enabled. The WLAN settings are configured. Select the interface. This is going to be the interface that will carry the WLAN traffic. Secure the WLAN. The security tab is used to access all the available options for securing your WLAN. You're going to verify it's operational. The WLAN's menu on the left is used to view the newly configured WLAN and its settings. Then you need to monitor this WLAN. The Monitor tab is used to access the advanced summary page and confirm that wireless_LAN now has one client using its services. You can view wireless client details when you click on the clients in the left menu to view more information about the clients connected to your WLAN. Now, SNMP and Radius. So PCA is running Simple Network Management Protocol and Remote Authentication Dial-In User Service, which is a Radius server. So the network administrator wants the WLAN, I keep saying WLAN, I apologize, wireless link controller to forward all SNMP messages, referred to as traps, to the SNMP server. The network admin wants to use a Radius server for authentication, authorization, and accounting. Users will enter their username and password credentials, which will be verified by that Radius server. The Radius server is required for WLANs that are using WPA2 enterprise authentication. SNMP server in Radius server configuration is beyond the scope of this module. Now, to enable it here, click the Management tab, to access a variety of management features. Click SNMP to expand the submenus. Click Trap Receivers. Trap meaning what type of messages do we want to automatically send to our server. Click New to configure a new trap. To configure a new trap receiver being sent to your server. Enter the SNMP community name and the IP address, either 6 or 4 for the SNMP server, and then click Apply. The wireless link controller will now forward all log messages to that server. To configure with a Radius server. You're going to click on Security. You're going to click on Radius. You're going to click Authentication. Then you're going to click New. You're going to add PCA as the Radius server. Enter the IP address for PCA and the shared secret that will be used between the controller and the server, and then click Apply. After clicking Apply, the list of configured Radius authentication server refreshes with the new server listed. Now, a topology with a WLAN 5 addressing. So each WLAN configured on the controller needs its own virtual interface. So the controller has 5 physical data ports that can be configured to support multiple WLANs and virtual interfaces. The new WLAN will use interface WLAN 5 in network 192.168.5.0, and therefore R1 has been configured for WLAN 5 as shown, and seeing it in the Show IP interface brief. So you see the subinterface of Fast Ethernet 01.5 coming off of your WLAN controller. WLAN interface configuration on your controller includes the following steps. You're going to create a new interface. You're going to create or configure the WLAN name and ID. You're going to configure the port in the interface address. You're going to configure the DHCP server address. You're going to apply and confirm and then verify. To create a new interface, you click Controller, Interfaces, New. Configure the WLAN name and the ID. In the example, the new interface is named WLAN 5 and the WLAN ID is 5. Configure the port and interface address. On the interface edit page, configure the physical port. The WLCG1 interface is port number 1 on the controller. The WLAN 5 interface addressing and the default gateway should be applied there. Then you're going to go ahead and configure your DHCP server address. The example configures a primary DHCP server at the IP address of 192.168.5.1, which is the default gateway router's address, which is enabled as your DHCP server. You're going to click Apply and Confirm. You're going to scroll to the top and click Apply, and then click OK for the warning message. Then you want to verify your interfaces. Click on Interfaces to verify that the new WLAN 5 interface is shown in the list of interfaces. And it is. Now, to configure a DHCP scope, it includes the following steps. Create a new DHCP scope, name your scope, verify the new scope, configure and enable the new scope, and then verify the enable scope. Excuse me. So you're going to you're going to create a new scope. In order to do so, you click Internal DHCP Server, then Scope, then New. You're going to name it. In this instance, it is being named the Wireless Management, and then you hit Apply. In the DHCP Scope page, click the new scope name to configure the scope. On the Edit screen for the Wireless Management scope, configure a pool of addresses, the default router IP address, then Enabled and Apply. To verify, the administrator is returned to the Scopes page where they can verify the scope is ready to be allocated to a new WLAN. By default, all newly created WLANs on the controller will use WPA2 with AES. 802.1x is your default key management protocol used to communicate with that server. Create a new WLAN to use interface WLAN 5. Those steps are going to include creating the new WLAN, configuring the WLAN's name in SSID, enabling the WLAN for WLAN 5, verifying AES and 802.1x defaults, configure your securities to use the Radius server, and then verifying that your WLAN is available. So click the WLAN tab and go to Create New WLAN. Enter the profile name in the SSID, choose an ID of 5, and then click the Apply to create your new WLAN. Once the WLAN is created, change the status to Enabled, choose WLAN 5 from the Interface Group drop-down list, and then click Apply and OK. Click the Security tab to view the default security configuration for your new WLAN. To select the Radius server that will be used to authenticate WLAN users, you click on the AAA Servers tab. You select the Radius server that was configured on the controller previously, and then apply your changes. You then want to verify that the new WLAN is listed and enabled by clicking on the WLAN submenu. Troubleshooting. Network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem, determine the cause of the error before anything can be resolved. Before they can resolve the network issue. This process is referred to as troubleshooting. Troubleshooting any sort of a network problem should follow a systematic approach. A common and efficient troubleshooting methodology is based on the scientific method and can be broken into the 6 main steps shown in the table on the next slide. Identify the problem. So the first step in the troubleshooting process is to identify the problem. While tools can be used in this step, a conversation with the user is often very helpful. Next, you want to establish a theory of probable causes. After you have spoken to the user and identified the problem, you can try and establish a theory of probable causes. This step often yields more than a few probable causes to the problem. Next, you want to test your theory to determine the cause. Based on your probable causes, test your theories to determine which one is the cause of the problem. A technician will often apply a quick procedure to test and see if it solves the problem. If a quick procedure does not correct the problem, you might need to research the problem further to establish the exact cause. After that, you're going to establish a plan of action to resolve the problem and implement the solution. So after you have determined the exact cause of the problem, establish a plan of action to resolve the problem and implement the solution. You're then going to verify full system functionality and implement preventative measures. After you have corrected the problem, verify full functionality and, if applicable, implement preventable measures, meaning tell them what you did. Document findings, actions, and outcomes. In your final step of troubleshooting, document your findings, actions, and outcomes. This is very important for future reference. So you want to document things that did not work as well as things that did work and solve your problem. If there is no connectivity, check the following. Confirm the network configuration on the PC using the IP config command. Confirm that the device can connect to the wired network. Ping a known IP address. If needed, reload drivers as appropriate for the client or try a different wireless NIC. If the wireless NIC of the client is working, check your security mode and your encryption settings on the client. If the PC is operational but the wireless connection is performing poorly, check the following. Is the PC out of planned coverage area? Check the channel settings on the wireless client. Check for interference with the 2.4 gigahertz band. Next, ensure that all devices are actually in place. Consider a possible physical security issue. Is there power to all devices and are they powered on? Finally, inspect your link lights between cabled devices looking for bad connectors or damaged or missing cables. I said link lights, I meant links. If the physical plant is in place, verify the wired LAN by pinging devices, including the access point. If connectivity still fails at this point, perhaps something is wrong with your AP or its configuration. When the user PC is eliminated as the source of the problem and the physical status of the device is confirmed, then you need to start investigating your AP. First, check the power source or power status of your AP. When your network is slow, to optimize and increase the bandwidth of 802.11 dual band routers and APs, upgrade your wireless clients. Older 802.11, B, G, and even 11N can slow the entire WLAN. For best performance, all wireless devices should support the same highest acceptable standard. Split your traffic. The easiest way to improve wireless performance is to split the wireless traffic between those channels. Therefore, 802.11n or better can use the two bands as two separate wireless networks to help manage your traffic. There are several reasons for using a split the traffic approach. The 2.4 gigahertz band may be suitable for basic internet traffic that is not time sensitive. The bandwidth may still be shared by other nearby WLANs. The 5 gigahertz is much less crowded than the 2.4, so it's ideal for streaming your multimedia. The 5 band also has more channels. Therefore, the channel chosen is likely interference-free. By default, dual band routers and APs use the same network name on both the 2.4 and the 5 point. It may be useful to segment your traffic. The simplest way to segment traffic is to rename one of the wireless networks. To improve the range of wireless network, ensure that the wireless router or AP location is free of obstructions, such as furniture, fixtures, and tall appliances. These can block your signal, which is going to shorten the range of your WLAN. If this still does not solve your problem, then a Wi-Fi range extender or deploying the Powerline wireless technology may be used. Updating your firmware. Most wireless routers and APs offer upgradable firmware that should be periodically verified. On the wireless LAN controller, there will most likely be the ability to upgrade the firmware on all APs that the WLC controls. So in this figure, the firmware image that will be used to upgrade all the APs is downloaded. On the Cisco 3504 wireless controller, you click Wireless, Access Points, Global Configuration, and then scroll to the bottom of the page for the AP image pre-download selection. So pretty much a basic storytelling PowerPoint here on how you can go into your home router and do some configurations. This has to do with the PT lab that you have to do, and also the second troubleshooting lab that I handed out the other night. So good luck and have fun.